We're going to take a look at the finding a monomial GCF. So this is going to be finding a GCF of something that has a variable in it. So these monomials are going to be made up of two parts. So the first part is going to be the coefficient part. Okay, so that's kind of, we want to think about that as the number. And the second part is going to be a variable part. So these are things like X, Y, Z, letters. So we're going to find the GCF of the coefficient part just as we did in some of the previous videos. And then we're going to take a look at how to find the GCF of the variable part here. So what we're doing is we're finding all the variables that the monomials have in common and just combining them. So that's our first method. So the way that we do this is by remembering that factors are always less than or equal to the original number. Okay, and I'm actually going to go ahead and cover some of this up so that we have some workspace. So whenever we're looking at variables and we're thinking about a GCF having to be smaller than the original, smaller or equal to the original numbers, we want to be thinking about picking out the least amount of any variable. So if we're finding the GCF of these two monomials, so we don't have a number part that we're worrying about here, but we do want to find the GCF. So what we're going to do is look at each variable separately and pick out only what they have in common. So let's at the x's and think about this first. So x to the third is essentially saying we have an x times x times x. X squared is essentially x times x. So if we're thinking about the number of x's they have in common, they only have 2. So that would be our lower exponent, x to the second power. So then we want to look at the y's. So we're not going to write it out this time. We're just going to pick the lower exponent. Because if the first one has y to the fourth, or y times y times y times y, 4 of them, and the second one has y to the first, just y, then they only have one y in common. So we would just bring down a y. Looking at the z's, we have a z to the fifth and a z to the eighth, and the smaller one is our z to the fifth. The nice way of doing it this way is that we don't have to spend a lot of time rewriting everything, and we can focus on what they have in common. So let's look at the other way. It's a little bit more roundabout, but it'll get us there just as well. All right, so I'm going to go ahead and erase this and actually do the example. Okay, so we have the GCF, we're finding the GCF of 32 x cubed y cubed and 40 x squared y to the fourth. So we're going to go ahead and factor all of this. So for the coefficients, just go ahead and do your prime factorization. 32 is 2 times 2 times 2 times 2 times 2. And when we do the prime factorization of our variables, we essentially just want to break down what that exponent is telling us. So x to the third means x times x times x. Y cubed means y times y times y. Okay, and we're going to break down the other one too. So 40, when we go ahead and find the prime factorization of that, it is 2 times 2 times 5. Oops, I need another 2 times 5. Then we'll have x times x for x squared, and y times y times y times y for y to the fourth. And just like before, we're going to pick out our common factors. So they have a 2 in common, another 2, another 2. They have an x in common, another x, and then a y, another y, and another y. And now we need to condense this into our GCF. So our GCF is going to equal 2 times 2 times 2 times x times y times y times y. But we can't leave it like that. 2 times 2 times 2 is 8. X times x is an x squared. Y times y times y is a y to the third. So you can see this takes a little bit more time than the other method because we have to factor, right? Expand it all out, find our common factors, and then condense it back after multiplying. I'm going to be going with method 1 when I do my examples, but if you're more comfortable with method 2, feel free to go ahead and use that. So first example, I'm going to go ahead and find the GCF of those numbers first, the coefficients, 12 and 24. And I'm going to do that the same way I did in the previous videos, finding the prime factorization real quick, and then going ahead and multiplying their common factors. Okay, so here's our prime factorization for the number. And we can see we have a pair of 2s, and a pair of 3. So 2 times 2 is 4, times 3 is 12. So our coefficient GCF, or the GCF of the numbers, is 12. And then we want to look at the variables. So remember, factors have to be less than or equal to their original values that you're finding the factors of. So if we look at the x's, the lower number of x's, or the lowest exponent, is an x squared. Y's, y to the first is smaller than y to the fourth. So we're going to end up with a y to the first. And for the z's, we have a z to the fourth, and then we have nothing, right? So no z's is smaller than a z to the fourth, so we would just leave it. All right, so again, let's do the GCF here of 2. Not of 2, but a problem number 2. All right, so we want to find the GCF of the numbers. So 21 is really 3 times 7. 35 is really 5 times 7. And 42, prime factorize that as 2 times 3 times 7. So the only factor that they have in common is 7. So the greatest common factor of 21, 35, and 42 will be 7. Now let's look at their variables. So starting with A, we have an A squared, A cubed. Well, A is the smallest, all right? So we have A. Now B, we have a B, B squared, B squared. B, or B to the first, is smallest. And now C, C to the fifth, C cubed, C squared is the smallest. And that is our greatest common factor of those 3 monomials.